answer gets you to 6. There you go. So now we got them equal. Okay. So again, remember, you take your permutation, and then you're dividing it by the number of ways to arrange however many slots you have filled in. Okay. Now let's move on to the next one. Okay, so a committee has 8 members. How many different ways can a president and a vice president be chosen? So you guys should have some practice with this one. So we know that there's a president and a vice president. So we have different roles here. So different roles. So we know if there's different roles, like different rankings, we know the order does matter. And by that way, I mean, like, let's say we have 2 slots. Let's say we have a president and a VP. So a president, VP. So let's say that Ms. Harrod was president and I, Ms. Brasso, was the vice president. That's not equivalent. That's different than if Ms. Brasso was president and Ms. Harrod was the vice president. That's what I mean by order matters. If it didn't matter, they would be equal. And we'll go into the next example for that. But so now we can do our little slots here. So president, VP, we have 8 people total. We know N equals 8, and R is 2 because that's how many slots we're picking. We're picking the president and the vice president. We have 8, come on, 8 times 7, because if we already assigned a president, there's one less position for someone for the vice president, and that equals 56. And you could also just type in, since it's a permutation, you could type in 8p2, and that would still get you 56 if you type that out on a calculator. Now for part B, it says how many different ways can 2 senators be chosen from a group of 8 people? Okay, so we have N, still 8, so our N and R are still the same exact thing. But does the order matter is the question. So we have 2 senators. So are they having different roles? Like, are they differently ranked differently? No, they're not. So in this case, order doesn't matter. And if order doesn't matter, we know it's a combination. So you could either type in 8C2 on your calculator, and then here's the conceptual understanding of it. We have it's still the same beginning where there's 8 spots for the president, now we have 2 senators, senator and senator. And then we still have 7 spots for that second, so we have 56. But then you also have to keep in mind that you have to divide. You have to take 56 and divide it by the number of ways to arrange those 2 senators. So then you would take 56. Oh, come on, marker. There we go. Over 2 factorial. And then that would get you to 28. And again, I'll help. So let's say we have our blanks here. We have 1 senator, 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 senator. Let's say Miss Harrod and I are both chosen as senator. Let's say she's chosen first, I'm chosen second. That's the same thing as if I was chosen first and she was chosen second. So these are equivalent. So that if they are equivalent, that's when you divide by however many ways you can arrange them. Okay. And that gets you still your answer of 28 if you type it into your calculator. So how are they different? Well, one is a combination. So part B was a combination, and then part A was our permutation. And in combinations, remember, order does not matter. But in permutations, remember, order does matter. And again, these 2 little examples here might help you guys with that understanding. Why the order makes it different. So now as we go into permutation versus combination, we'll be doing this in the next lesson, but I'm going to briefly go into it right now. With permutations, order does matter, so it's going to be your president type problems. Think permutation, president type problems. In your combinations, order doesn't matter, so combinations, think committee type problems. And again, we'll go into more depth with this next lesson. So let's briefly try to figure out, let's see, for part A, this is going to be a permutation or a combination. So 4 people are lining up. So 4 people lining up, if they're in a line, order is going to matter. So we know that's going to be a permutation. And then for the next one, part B, Mr. Feig's picking 4 students from first hour. Do these 4 students have different roles? No, they do not. So order does not matter. So that is a combination. Okay, part C, choosing first and second place from a race with 10 runners. Think first and second place. So there's different roles, different rankings. So that is a permutation since that order does matter. Okay, so now we're choosing 3 out of 5 candy bars to buy to checkout. Are these candy bars being ranked differently? Like, does the order matter of how you buy those candy bars? No, it does not. So it is a combination. For instance, if you pick to buy a Reese's first and you pick to buy a Twix bar second, it'd be the same thing as if you picked a Twix bar first and a Reese's second. That's why that order doesn't matter. Then for E, picking the top 2 horses, this it kind of depends on how you look at it, but I'm looking at it as in they're not being ranked differently. It's just you're picking your top 2. You're not picking your first and your second. You're just picking top 2. So that order doesn't matter. So it's combination. And now for this one, you're choosing a treasurer and a manager. They have different rankings because they're different roles. So the order matters. Permutation. And then this one, selecting 2 co-captains. These have the same ranking, the same role, like if it was 2 senators or 2 committee members. So it's a combination because order does not matter. So again, remember to do your homework checks and make sure you guys are doing the attendance. And please feel free to email if you have any form of questions. Thanks.